Hi everyone, welcome back to Ken's Lab. Here I have an oscilloscope, very old, round CRT type. No graticals on there, so you just went by waveform. It doesn't work, so it's going to be repaired if possible. And as the old style, it doesn't have probes. Looks like it takes the banana plugs, when actually they would have alligator clips on the end, and you can adjust the input by either x1 or times 10 or times 100. Okay, we have what we have up here: intensity. It's got to be brightness, I suppose. It's on and off. Focus, vertical position, and horizontal position, and your vertical gain, horizontal frequency selector. Here, that was vertical gain. This is horizontal gain. Okay. Then you got your selector for your inputs, which would be just an alligator clip. And this is the frequency linear. What we have here, the phase. Buttons are a little hard to turn. The sync selector, internal plus internal, blind and external. This is the sync amplitude. Okay, here's a little light on here showing you have power. These are for your vertical input, and this is for horizontal. And then down here it says 1-3 or something, external. This thing is would be a monster compared to oscilloscopes today, because it's going to take a lot more abuse as far as you're not going to really destroy the front end or anything. It's got a dent in it right here. It took a lick from something. What was that? Well, it just says grounds. We know what it is. I don't have a model number on it. It just says Heathkit Laboratory Oscilloscope. The Heathkit Company, Benton Harbor, Michigan. And nothing on the outsides, around the sides. Nothing on the back. There's a little door here, access door. And under the bottom, let's see what we have. Nothing. It looks like it's got a little dent in it. Still got some rubber feet on it, but it doesn't work. So what are we going to do? We're going to take it open to see what's in there. And first thing we'll do, I guess, is check the CRT. If I have my CRT testers, will take this. It's heavy. Gotta lift it up, I guess. Get it out of there. Pull my cord through. Power cord. Yeah. Get this out of my way for a little bit. Yeah, there's, maybe he tells me something here. Get this out of the way for right now. What we're looking at. You know, this is like a regular antenna wire there. All these tubes are like kind of pulled out. Where I looking at? Printed circuit boards. Kind of weird. Yeah, this controls look a little corroded. Microfarad. There's a E-cap there. Can E-cap. Another E-cap there. I'm just seeing if I see anything out of whack. Quite a little bluish there. This grommet, I wonder if it's dry rotted on this tube. Oh, there's another electrolytic there too. Where is these? Okay, here we go. Another electrolytic. All these capacitors will have to be replaced if this thing works. Let's take a look at the bottom. Let's just see how it looks. Oh yeah, there you go. Yeah, one capacitor looks like it's shot. Are those hooked up in parallel? They are. Let's turn it on this end here, you can see. God bless it. Boy, that's a big power transformer. Yep. So, can I fix it? I don't know. Yeah, here we go. A 0.1 and a 0.1. Connected to the ground. And those are 1600 volts each. Okay. I'm ready to check this CRT out. Well, I got some. I had to get the pin out for it because nothing. And one of them called it a CRT picture tube. Well, it ain't a picture tube. Well, I don't need to see that. What I'm doing, I've got the overhead camera going to also record. I got everything set. I got the gun selector at scope. Red, black, and white in scope. And I got the CRT type is on scope. Okay, I got all the settings as far as the cathode, G1, G2, F1, F2, and film voltage and stuff. I gotta set that one to power it on. So we're gonna turn it on. Alright, I'm seeing some deflection on that, so it's showing me maybe that heater's good. Yeah, and I'm gonna bring that up to what? What do I need that to be? What is that heater on that thing? Does it tell me? Voltage is 6.3. I would think I'd been. So we'll set that to 6.3. Whoa, 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 whoa. Filament setting. It went down on me for some strange reason. But it's there. At this point, I should see that tube light up in the back, and I do. I can see it. It's strong. Okay, we're at 6.3. All right, now that's the filament. Now we're going to heater and cathode. Short. It's reading good. Stay there. Steady, steady, steady. Okay, now we're going to go grid 1 short. Oh, that's good. Set the cutoff. Wow, I better have some cutoff settings. Hell yeah. Yeah. Let's find it. Get the cutoff setting. This is good. So far. Okay, get back in there in a happy medium place. Right there is good. Okay, and now the emissions. Wow, it's reading good. It is reading good. It's reading, wow, and it's getting stronger. It's getting closer to the 150 milliamp. The strongest it can be. Just about it. Let that settle for a second, then I'm going to do a live test on it. And see what happens there. It's showing good. That's great. Emission test. All right. It's close. It's about halfway. It's about 10, 20, 30, 40. About 145 milliamps, let's say. 142 or something. Maximum is 150. Emission test. I'm pushing it in. Live test I'm talking about. It hasn't budged. Well, it is going down a hair. I mean hair. Right now we're at 10, 20, 30. About 140. And staying. That's a good CRT. It's like what I can see. Turn it off. It passed the test. Okay, here's those 1600 watt point ones that I took off from here. I'm putting them on this rack because they're leaking so bad. Goodall is a good capacitor if they were milers, plastic milers. I would, those are really good capacitors. Those last like forever. But these wax jobbers, you can tell they're leaking all over. I don't like touching. Shoot, can't even touch the wires. So I'm going to dispose of these. I'm getting them off my workbench. It just causing me a problem. Getting in my way. Sticky things. Now, I have 3 tubes here that were bad. I had let's go with these 2 first. That 1V2. That's what they call a low rectifier. These things here is 1V2. That sounds like a high voltage rectifier for a television or something. I mean, it ain't, but the heater element's open. And then this one is it 6x4, I think it is. Yeah, 6x4. Another rectifier. Like this is the full wave. I'll have to get that print out there. I got one. I'm going to use this one. I was looking at a stupid wrong model, and something don't jive with those tubes. So I thought it was at 012. Well, it was 012, but it's a 010. They look pretty much alike, but that 6x4. Yeah, that's a full wave, and the other one's just a half wave. And this heater is open also. And this one over here is a 12BHT. It's pegging when you check for grid leakage. I mean, it just pegs. So, and other than that, all the other ones were pretty good. All in all, they were good. So, I'm trying to figure out why would the 2 rectifiers, the heaters, go out on them. I mean, it's got to be a reason. And I got nothing. Frank at Exeter's Lab, he got him a new multimeter, and he had a good idea of putting it's a tripod like stand I don't know, little bitty guys to use for your camera, I think. Well, as close as I got right here. Right now until I get one. I don't have one. I have one, but it's way too small. Turn this on. Hope you can see that one. Let me turn it this way. See that it works. It should be read all. Okay. Now we're going to try that 20. Nothing. 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 That's open. Never seen that before. Now we'll try this other side over here. So, that's reading like 1 ohm. It's borderline. It says compare. I don't have to compare. Now that one's open. That one's good. Come on, get on there. And that one's good. That one even there is open. I don't know which one it is. Perhaps you can see it now. There's a look at a spark right there. Is that like a burn spot right there? Turn that around. I don't know. It's laying right there. Why? That resistor is good. That's the 5K. I thought that was. Yeah, the 5K. But it sure does look like that. Can't turn that wire around. I don't feel it. I'm gonna throw something, liquid tape on that or something. I think I got everything done on this oscilloscope. Even had to set these knobs correctly, clean them up. Some of them are really, really hard to turn, and after a few days, after cleaning them, they're turning good. All right. First of all, I had to take this CRT out. For one thing, not to damage it, it's easy access to the parts. I'll see if I can bring this up a little bit. We'll see. A lot of work done on this. So all of the capacitors, I think those were, well, there was electrolytics, and there's some plastic milers in there. So I changed there was, how many, like 16 of them, and that's not including the E-caps. So, and 22 resistors that were out of tolerance. But I got it all back, and here, maybe you can see back here, that's that 320s in this can. All of them were open, nothing. So I put 20s in there, and I put a ring around there and soldered it on because 2 of them were grounded, third one wasn't. But get them all grounded. I did that. You'll see when I get on the bottom. Yeah, I cleaned all the pots out, the switches. Cleaned this wire up. There was one wire back in there on this side. Here's it's a jumper wire, a bare wire. It was pushed up against the resistor, and I don't know which one it is. Wish they'd give you. Let me see my flashlight a second. I know which one it was, but there's so many of those. Maybe that's 470K. Maybe I can find it in the print. Let's see which one it is. So what I'm waiting on that 2 rectifier tubes. I had the heaters open, and then at 12 of BH7, I think it was, 12 HB7. God. 12 BH7. And that is your, I think that's the vertical deflection amplifier, because it's a twin triode tube. And that was the one that was pegging the grids. And I got the printout for that tube, and there's no way that should read. So I got all of them. Then I got these all done on this board. Everything that should be replaced. Turn it around. Back it up a little bit because you probably couldn't see what I just showed you. And I put the tubes back in, the ones that were good. Oh man. Back it out just a little bit. And then again here, side of the board. I don't see any, there's no calibration to be done on this thing as far as I can tell. There's coils in here on this board. There's like 4 of them. They're not adjustable. The only thing is adjustable is this right here. I think this is just that little dot on the screen to get it right in the center. But I don't know. This here is at what did it say in there? Is that Z-axis? Plug something in there, and I don't know if it has anything to do with that other adjustment. There's no adjustment. I changed the one of the resistors on this socket. Okay, but yeah, it's all done on the top. I even got the wires lifted up. I had to redress a couple of the wires. This wire was sitting on top of this resistor. I didn't like it, and I put a wire tie up here and made it look less congested. Okay, I want to show you underneath it. It's all done under there. Capacitor there, I put in there. Resistors I did replace somewhere on this thing. Back there, one of these, what was that switch? Oh, that was the vertical input. One of the resistors. By all tolerance. Now the bring it down just a hair. This, that's that can back there in the back. I got that documented somewhere, what was in there. A 40, a 20, a 20, and a 50. So I put my isolated standoffs in there like usual and connected them to that existing terminals or plugs on that capacitor, and then put them in there. This is that 50. It's why so much bigger. So yeah, I got that done. Put a fuse in here. It wasn't fused, and it should have been fused. I put a 1.5. I'm still waiting for the what was that? 1600.1s. I need 2 of them. They're coming in. So I'm waiting on 3 tubes and 2. Actually, I ordered a bunch of capacitors, but I made sure I got these 1600. And there is 2 1600s in there. And now the circuits. One on this board and one on the bottom board here. They're 1600s, but they're the ceramic disc. And I checked them for .02 and I read .02, but that's all I could do. So I got my new capacitors in today. 1600 volt point ones, 2 of them. So that's done. I got my tubes in today too. Perfect timing. My 1D2. Everyone I checked, the 6X4 and that 12BH7 I think it was. Yeah, 12BH7. I checked them all and they checked out good. So guess what? It's time for power it on. Okay, this is off. Let's turn this on. Here. Turning on the... Oh boy, oh boy, oh boy. Let me see what kind of voltage we got going to it. It should take 125 volts. 123, that's what's going to be. And we're going to pull the amps on it because I want to see what kind of current we're drawing. Okay, here we go. No lights, no DVTs. I didn't see the actual pole on it. I was too busy looking at everything else. Hey, okay, I'm seeing some tubes lighted. Hey, my 6X4 is lighting. That one, I don't know. Okay, baby, do something. Probably take a while for it. See if that CRT is lit up back there, and it sure is. Intensity. I'm not seeing nothing. Really? Come on, guys. I don't need the focus. Maybe I need something on it. I don't think so. It should light up with a green dot or something. Come on, be good. I'm not seeing nothing. Well, doggone it. I'm pulling 697 milliamps. So I got it. It should have something on it. External input. That dot thing, I can go ahead and turn that, I guess. That makes that dot brighter, or bigger, I should say. Doesn't make it, it'll make it bigger or more round. That ain't gonna help me. Focus don't mean dick. I got the intensity all the way up. It should be bright as hell. Vertical and stuff like that don't mean nothing. Not at this point. Horizontal gain and vertical gain. Let's just try it. Frequency, I'm not sure what that does at this point. Actually nothing. Sync. What we got here? The phase. That's for something else. Just leave it on halfway. And I got nothing, guys. Doggone it. All of this. That tube's gotta be shot. See, it's definitely the CRT. Let me see here. Pin 1 is here. Not worried about that one. Pin 2, grid number 1. That should read a negative 1200 volts. I got it set on here at 1000. I just want to touch it just very fast. So that's 1, 2, and 3. Should go on, just touch it. See, and that's 3. I mean, what was that? Pin 1, 2. That's grid number 1. Minus 1200 volts. Really? For pin 2. So I'm getting that. I mean, it's there. 1, 2, and 3. Ah, shit. What did you do, Kenneth? When I do that, my computer screen goes blank. Let me see what I'm pushing on there. I'm pushing. I've got amps at almost 695. Of course, and I had watts up here. 72. I think I read 80 on there somewhere, maybe, on the watts. But anyway, now I'll go back to pin 2. Hope you can see that meter. Let's see if I can bring it in a little bit. Get this a little closer. Alright. So many things to focus on. Pin 2, minus 1200, and pin 2 is grid number 1. So that's 1, 2. Right here. Whoa, hold it on there, Kenneth. That's there. That voltage is there. That's pegging them, you know. Pin 3 is the cathode. That's 1060 and varies with the intensity setting. And I got the intensity all the way down. So I'm looking at pin 3 right here. You know, it's there. Pin 4. Anode, number 1, pin 4. S minus 730. Let's see what we got there. 1, 2, 3, right here. Okay, that's good. But I get it set on 1000, so that's 600, 720. 730. It's, you know, that's there. What was that one? That was the pin 4. 1, 2, 3, 4. Which is your anode, number 1. Now your pin 5 is at the internal connection. You're not really, what the heck is that? That's no connection, okay? 1, 2, 3, 4, 5. Pin 6 is 260 volts. I can measure that with this one. Pin 6, 260. 1, 2, 3, 4, 5, 6. 233 with varies with position of control settings. Come on, stay on her, Kenneth. 233. And I'm supposed to be getting 260. It's there. This one again, 286. Let me put it in front of you. Over here. So you can see that one. I don't pull all my wires loose. So here it's supposed to be 260. I'm getting 233. That depends on varies with position control settings. Okay, this one 286. That's a little high on pin 7. 1, 2, 3, 4, 5, 6, 7. Because of the settings, obviously. And pin this one, I guess, 260, and I'm supposed to be getting 260, and 5, 6, 7, and 8. 8, 8, 8. 12, 11, 10, 9, 8, right here. 260. Pin 9, 275. 195. That depends on position of the control settings. So they're there. That's all four. Those are those deflecting electrodes. All four of them. Number 10 is deflecting coil. Yeah, and 10. 1, 2. Oh no, I'm sorry. Pin 8 was that grid number 2 with the anode. That's 8. We had that one. So everything is showing that pin 10 is 250. Right here should be 10, 11, 12, I think right here. 300, and that depends on the control settings. And then all we got there is pin 12, HVH. And 12, what was 12? That's the heater, the other side of the heater. We know the heater's going because you can see it lit up in it, and we showed that on the CRT tester. So, I've checked the voltages, they're good. It should give me a, that screen should light up. Get these out of my way so I can turn this thing around. So it's the CRT. I only one can hope. I mean, it's those CRT checkers are really great, but don't necessarily mean it's going to work. Turn it back around, and we got nothing. Well, it should do something. I'll turn the intensity back up because I had it all the way down, and it's dead. My scope CRT came in. Ordered this Monday. Here it is Thursday. Was it coming from New York, wasn't it? Yeah, New York. Pretty fast. Cost me $35 for the CRT. More for the shipping. But that's still reasonable, I suppose. And I got a 30-day return policy, so that I have to have. Easy does it, and here it is. Nice and clean. Well, it looks shorter, but it ain't. This is an RCA. Oh, I thought, yes, an RCA. Base is nice and tight. Nice and clean. So, let me let you roll off. He wants to roll. Okay. There it is. I just got to put this in. And hopefully it will come to life. Gotta put this over so it don't fall off on this rat traps. So give me. Okay. There's the new one in there. Let's give this thing a try. Switch is off. Alright. I'm gonna check the amperes while I'm at it. Okay, here we go. I hear something different. Come on, baby. Probably turn its intensity up. Nothing. There it is. There it is. See a dot? Let's see if we can see. This is. I can see a dot. I don't know if you can see that. There it is. Bring it up in the center here. What's the dot in the middle? There it is. I had to bring the intensity up on this one. Okay, now I want to see if I can adjust that dot. Maybe in focus. Look at that. I'll do that like that right now so I can see the dot. There it is, perfectly round pretty much. All right. There it is. Nice and bright too. Okay, it's working. You can see the dot. Waveform. Just a line. There we go. Now that's what I'm talking about. Now if I can only stop this thing, stop this crazy thing, I think all I can do is just horizontal position. Vertical you need. No, you don't. You need the gain or something. Yeah, there we go. But I'd like to stop it. We're close. There we go. We just have to bring this horizontal gain where you can see it. That's the wave I'm looking for. That's at 60 hertz. Now that's what I wanted to see. For 60 hertz. You just gotta get used to. Oh, cool. The circle, it's round. That's the one I wanted on. Oh, I'm hitting the wrong one. Horizontal. All right, it's working. Things. Let's try vertical. I'll turn this power off. So, I've had this oscilloscope down in the basement for ages. And when I redid this lab, I thought, you know what? I'm bringing some stuff up. I saw that one. I said, well, I'd like to get that thing working, because I knew it didn't work. And so I brought it up, and finally I get at it. And I was kind of expecting a CRT to be bad, and then when I got the voltages that I'm supposed to have, I knew it. So now all I got to do, and you can see all the stuff I did under the bottom. Well, you've seen that. So all I got to do now is just take these banana plugs out of here and get in here and block of wood and stuff and bend that straight, and then put it back, clean out the cabinet, the case, and put it back in there. So all I got left to do. So hope you found it interesting. I had fun actually servicing this. So thanks for watching. We'll see you next time with another project. it.